Hmm. Right, hello, everybody. We are doing some maths today, focusing mainly on foundation level papers. I've opened up a couple. If you're doing different exam boards, I will do some AQA questions as well. I've got it all ready to go. If you have any specific questions and things, there's a Q&A and a chat. Both seem to work. So you should be able to answer things or ask for any specific things that you like. My intention is to start with at least to largely just go through a paper, and I'll stick to non-calculator mainly because it's first, but we can move on to other stuff if necessary. Hello. Um, and you can let me know if there's anything specific that you don't understand or what we can do, and I can try and find some questions around it. What I tend to do is use Maths Genie to find specific topics if there are specific topics. Otherwise, I always think the best point at this point, assuming you are in year 11, assuming you're in year 11, that you just do papers and work backwards from there if you don't understand how to do a topic. So at least that way you're focusing your revision on things that you actually don't know rather than doing things that you are good at. So let's begin. This is a foundation level paper. So I would hope that for most people, the early questions are not going to be terribly challenging, so I'll get through them quite quickly. It's always, as is the case with most exams in maths, the second half of the paper that people tend to struggle with. So I will try to um, focus on that. In terms of what I'm doing today, I'm doing 2-ish hours now, and then I will be doing some science stuff at 3 o'clock as well, although that is going to be more sort of higher level triple science stuff if you're doing that. Um, these topics that you, yeah, I'm not, yeah, that's fine, no problem. Anybody in year 10 is here. That's not an issue. You can just um, listen in, and you will still be doing the majority of stuff that is very much relevant to you. All of those topics somebody has listed: trigonometry, vectors, direct and inverse proportion, growth and decay, area of parallelogram. I think I did that yesterday, so I won't do that. Angles on a straight line. Okay. Around a point. So okay, fine. I'll do a bit of angles. Um, Surface area of a cube. But yeah, I can do most of that stuff hopefully at different points today. Right, so let me just go through some of these. Some of these topics that you need help with will just come up as you just do a paper. So I've just picked the most recently available Edexcel paper here, but we can do anything, so it's fine. Here's a list of number. Work out the range of these numbers. Range means highest number take away lowest number. So the highest number in this group of numbers is 8. The lowest number is 2, therefore the range is 6. Work out 120, take away 89. Non-calculator, as I say. So this is how you would probably want to set this out if you can't do it in your head. I mean, the answer's 31, but let's just do it. So 0 take away 9 we can't do, so we borrow from there and put that one there. So 10 take away 9 is 1. 1 take away 8, once again, you can't do because you can't go to negative numbers when you do these things. So you have to borrow from this one. 11 take away 8 is 3, and then 0 is 0. So the answer is 31. That's that. Simplify the following. Right. When you are multiplying numbers and letters and so on together, any numbers that you see, multiply them as normal. So 3 times 4, 12. And then if there are any letters being multiplied as well, stick them on. So the A just sticks on. If there were more A's, for example, A times A, then you need to write that as A squared. But in this case, only one of them, so that would be the answer to that question. This one I can't do because I don't have a protractor that I can show you on screen. But what you would do with your protractor, if I can visualize what's going on here, is you would put it somewhere here with the middle bit there. That makes sense. And then you would just make sure the zero's there and then count and measure and see what this says. And it's going to be around, in my head, that looks around 35 degrees, something like that, because that's 90, 45, 35, 35, 40 degrees, roughly. But that's how you would go about doing that question. Work out 1/5 of 300. When you are working out a fraction of an amount, I always recommend doing the same thing, which is Take this number, divide it by the number at the bottom. So you need to do 300 divided by 5 first. That's how I would do 300 divided by 5. 5 doesn't go into 3, remainder 3. 5 goes into 36 times, if you know your times tables. And 5 goes into 0, 0 times, which means that that is 60. You then take your 60 and times it by the number you have at the top. Now, in this case, that doesn't make a difference. But if there was another number there, like a 2 or something like that, that would change the number. In this case, we just get 60. So that 1 goes there, right? And that 60 is there. So divide by the bottom number times by the top number. That's what you want to do. 3 liters of oil in a can. Jermaine uses 700 milliliters of the oil. Work out the amount of oil left in the can in milliliters. You are supposed to know that there are 1,000 milliliters in 1 liter. That is the beginning basis of this question. If there are 3 liters of oil in a can and 1 liter is 1,000 milliliters, it means that there are 3,000 milliliters of oil in the can. We are using 700 of them, and we need to work out how much is left. So we need to take away 700 from the original number. And if you follow the same method, you should get 2,300 for a takeaway question there. Again, if you have any questions or anything unsure, just write it. We'll deal with it. I'm the only one that can see the questions, I think, and the answers and the chat and everything. So say what you like. Okay, Matt is drawing a scale diagram. 1 centimeter represents 5 meters. So what that means is a bit like on a map. You have obviously on a map, you've made everything smaller than real life, obviously. And so there is a distance that represents a distance in real life. So in this case, we're saying that 1 centimeter, which is about that distance, represents 5 meters in real life. I should have said the thing that I'm doing is going up on our YouTube, so you can watch it back later should you want to. It's called Step to Success UK. So if you do youtube.com/that, you should be able to find it or just search for it. But I think you need to put the UK there because loads of people have the same sort of name. But if not, message us somewhere and I'll send it directly to you. But one of them that I did yesterday is on there. One of them that I did yesterday isn't on there, but it will because I've got it. I just haven't uploaded it. And then this should automatically go on after this later on. So we draw a line. So if 1 centimeter represents 5 meters in real life, we're now going to draw a line that's 3 centimeters long, which means that's 5 meters, 5 meters, 5 meters, which in real life would represent 15 meters. Then it says the real distance between 2 points is 20 meters. What is the distance between the 2 points on the scale diagram? Well, we've already know that 1 centimeter represents 5 meters. So I can't really draw this properly, but what we're saying is that if imagine that's 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter, then each 1 centimeter represents 5 meters. So that's 5 meters, 10 meters, 15 meters, 20 meters, which means this is essentially the line that we're talking about. The real distance is 20 meters. So on the diagram, it is these 4 centimeters, isn't it? So that's 4 centimeters there. I hate these, right? Miss Bailey asked 24 students where they wanted to go on a school trip. Here are the results. Complete the frequency table. Right. What you are supposed to do is count everything, all of the answers, do a tally, and then work out what the tally is based on that. I'll tell you how to do that. So what I'm going to do first is look at all the castles, right? So I've got 1, 2, 3, 4, 5. When you get to a fifth, you cross it out. Another one 6, another one 7, another one 8, another one 9, another one 10, cross it out again, and another one there 11. Is that all of them? That looks like all of them, so that is 11. Do the same with the farm. 1, let's do this quicker now. 1, 2, 3, 4, 5, 6, 7. So that's 1, 2, 3, 4, 5, 6, 7. And then the museum is the rest of them. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's your tally, and then your frequency is the actual number that the tally represents. Write down the place that is the mode. The mode is the most common value in a set of data. So it's the one that appears more than any of the other values. In this case, we've got 11 castle values, which is more than any of the other ones. We've got 7 farms, 6 museums. Castle, therefore, is the mode. Do not write 11 as the mode, which a lot of people would do. The 11 tells you that it's the highest, it's more than anything, but it's the value itself that is the mode. So, castle. Draw a bar chart to show the results. We've got 1176 for Castle Farm Museum. Okay, make sure you do a scale that fits what you've got. So I know it goes up to 11. So I'm just doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I've just put Castle Farm Museum down here. 11, 7, and 6. So you draw a bar for Castle up to 11. Do this a bit more neatly. What was it? 11, 7, and 6. And that should be it. 11, 7, and 6. Okay, probability. One thing that I will say about probability first is that if you see a question that says write down the probability, the first thing you should probably make sure you do is draw a line to represent the fraction that your answer is going to be. Majority of the time, the answer should be given as a fraction. And it just makes it easier if you do this so that you kind of know we need 2 numbers here. The bottom number of the fraction of your answer in a probability question should always be the total number of options. In this case, there's a bag of 22 counters. So I'm going to put 22 on the bottom to start with to make sure I've got that bit. The reason I say that is because sometimes people don't do this and they read the question wrong and they say something like red counter, which means 9, and they just put 9 as the answer without realizing that the answer should be a fraction with the total at the bottom. So in this case, the answer is 9 out of 22 because we're saying what's the probability this person takes a red counter from this bag? There are 9 red counters out of a total of 22 counters. So you do 9 out of 22 to do that. And then does not take a pink counter. Once again, this is still a probability question. I'm still going to put over 22 there because we've still got a total of 22. Now we just need to figure out how many are not pink. So not pink is these 5 and these 9. So that is 14 out of the 22. With this one, it takes a white counter. Again, what I might do, you don't need to do this bit, but I might just put over 22 again because we're still looking at the same scenario where it's out of 22. How many white counters are there? None. So you can put 0 out of 22, or what most people would have done is just put 0 because there are none. So either of those is fine. Okay, here are the ingredients to make 20 peanut butter cookies. Derek wants to make 60 cookies. He has 900 grams of peanut butter. Does he have enough peanut butter to make 60 cookies? With these questions, there will always be because you'll see these quite a lot, there will always be a recipe. And it will be a recipe for a certain number of items. In this case, 20 cookies. It's how many what ingredients you need to make 20. Then they will ask you a question about making a different number of items, in this case, 60. The easiest way to do this question without a calculator, at least, is to recognize whether there is a multiple that takes you from the recipe number to the number in the question. In this case, because there's 20 there and 60 here, I know that 60 is 3 times bigger than 20, which means that in terms of my ingredients, I need 3 times as many of the ingredients to make 3 times as many cookies. So the amount of eggs I need is 3 times the amount of eggs I needed for 20 peanut butter cookies, which is going to be 6 if I'm making 60 cookies. Let's do that here. If I need the sugar, I need 3 times as much sugar, so I would need 600 grams of sugar. For the peanut butter, I need 3 times as much peanut butter. So 250 times 3, if you don't know this, again, be able to do the things I'm doing here for a non-calculator paper, like work out that 0 times 3 is 0, 5 times 3 is 15, carry the 1, 2 times 3 is 6, add 1 is 7. That means we need 750 grams of peanut butter to make 60 cookies. He has 900 grams of peanut butter. Does he have enough? Yes, he does. because he only needs 750 grams, as I have just demonstrated. Okay. Ugh. Right. On this grid, draw an enlargement of the triangle with a scale factor of 3. That just means make the triangle 3 times bigger. So it doesn't matter even where you draw it. It just needs to be 3 times bigger. So the best way to do that accurately is to look for straight lines that are on the squares, like these, and say, well, that's 2 squares big. So my bigger triangle needs to be 3 times bigger than that. So it needs to be 6 squares across the bottom. So 1, 2, 3, 4, 5, 6. 6 squares across the bottom. Then, in this case, I would also check the height of the triangle, just the straight height. So that is 3 squares up from the center. 1, 2, 3. Which means if I triple that, because it's a scale factor 3, it will be 9 times up from the center. So 1, 2, 3, 4, 5, 6, 7, 8, 9 takes me to here. That is 9 squares up from the middle. And then use a ruler and join it up. And you have a triangle with scale factor 3. It doesn't matter where you draw this one. In higher level and stuff, you get something like a center of enlargement and stuff sometimes, which means that you do have to think about it a little bit. So it matters where it goes. In this case, it doesn't matter where it goes. Right. We have an equation or a formula. P equals 2G plus 4H. Work out the value of P when G equals 3 and H equals 5. Well, if G equals 3, then that means I put the number 3. Yes, you do. Sorry, I meant that particular easy question. So you said in foundation you get a scale. You mean a center of enlargement? I think that's what you mean, not a scale of enlargement. You do get that question, right? But if it's earlier on in the paper, in that case, you didn't. So anyway, for this question, G equals 3. So remember, what this means is if you have a number and a letter stuck together, it means 2 multiplied by the letter. So if the letter is 3 or represents 3, then 2 times 3 is 6. And then if you do the same with the H, if the H is 5, 4 times 5 is 20, which means your P is 26. Yeah. Work out the value of G when P is 38 and H equals 3. This will require a bit of rearranging. Let me rewrite the equation. Okay, now it says work out the value of G when P equals 38. So I'm going to change this P to 38 and H equals 3. So I leave that there. The H is 3 now, which means 4 times H, which is 4 times 3, which is 12. So I've just changed that to 12. And then I need to work out what G is. So this is where you need to try to be able to rearrange equations. We need to get the G by itself because it's asking you to work out the value of G. What I would do first, this is how lots of people explain this in slightly different ways, so just do it the way that you are comfortable with. I will first move this plus 12 and I subtract it to the other side. So it goes to the other side where it becomes a takeaway 12. Effectively, we take away 12 from both sides, leaving us with 2G on its own on that side and 38 take away 12, which is 26 on this side. Then we want to get the G by itself by moving the 2. The way we move the 2 is by dividing both sides by 2. And you end up with G equals 26 divided by 2, which is 13. And that would be the answer to that question. We've got another one with negatives, as usually happens here. V equals 3R minus Q. So let's just do the Q bit because that's easy. Q is just 2, so put minus 2 there. The Q's changed. And then R is minus 3. Just be really careful with this. If R is minus 3, then this becomes 3 times minus 3. Okay, because the R, we're multiplying by the R. 3 times minus 3 is minus 9. And then you have to do minus 9 minus 2, which is minus 11. If you're unsure about that, you've got to think of a number line think about which way you're going. If you're adding, you're going that way. If you're minusing, you're going that way. If you're on -9 and you take away 2, it means you go this way 2 steps to -10 and then -11. That's why it is -11. I remember this being really long. Right, Chloe is making scrunchies. Chloe has a large number of hairbands. Each hairband costs 8p. She buys 100 grams of wool for £3. Chloe uses one hairband and 5 grams of wool to make each scrunchie. She makes as many scrunchies as she can. Work out the total cost of each scrunchie that she makes. Give your answer in pence. So, a scrunchie is made from a hairband, which costs 8p, and 5 grams of wool. Now, I need to work out how much 5 grams of wool will cost. Okay, so we have bought 100 grams of wool for £3. Okay, that's what we bought. And we need to figure out what 5 grams of wool costs us. So there's a few different ways to do this. I'm going to change this to pence, so it'll be easier to calculate. So 100 grams is 300p. You could do what I'm about to do now. There's a few different ways to do this. I need to figure out what 5 grams of wool cost me. If 100 grams cost me £3, then what I could do is divide by 10 here and say, well, if 100 grams cost 300p, then 10 grams must have cost 30p. Then what I could do is half both of these and say, well, if 10 grams cost 30p, then 5 grams cost 15p. So I can see now that 5 grams of wool cost 15p, and we need to work out the total cost of each scrunchie. Well, we know that it uses a hairband that costs 8p and 5 grams of wool that cost me 15p, which means the total amount it cost is 23p. That was quicker than I thought it would be. Again, any questions, please feel free to shout. On this grid now, draw a graph of y equals 4x minus 1 for values of x from -2 to 2. Again, I think this is one of the topics that often people don't do very well. What you have to understand is that this equation, an equation is a little bit like a machine, where you can put numbers in and it spits numbers out. Now, what they're asking you to do is draw the line that shows that. Now, what we can do is put some numbers in, x numbers, and it will tell us the corresponding y numbers, which will tell us some points that I can draw a line through. And that's really what we're going to try and do here. So what I would do is I would draw a little table. Look what it says here, from -2 to 2. So I'm going to literally do that. Whole numbers from -2 to 2. -2, -1, 0, 1, 2. They are the whole numbers that go from -2 to 2. And these are all x values because it says x from -2 to 2. Then what I'm going to do is put y below it. And what I'm going to do now is make a little table and use this machine, as I like to call it, because I think it helps you understand, to find out what the y value is for each x value. So all we're going to do, a little bit like that question that I just did up here, where we had to substitute these numbers, like g equals 3, into where it said g, in exactly the same way, I'm going to put in these x values, these numbers, where it says x, and work out what y is. So let's start with the easy ones. 0. If I put 0 where that number is, or that letter is, 4 times 0 is 0. 0 take away 1 is -1. And we end up with y equals -1 when I put x is 0 into there. So as I say, the machine is telling me that when x is 0, y is -1. So I'm going to put that -1 there. Then we do the same thing with the 1. When x is 1, you do 4 times 1, which is 4, take away 1, which is 3. So I get y equals 3 when I put the number 1 into it. So I'm going to put that there. And you continue doing that for all of them. So if you do it with 2, 4 times 2 is 8. 8 take away 1 is 7. It's a little bit harder with the negative, so just take your time with it. But when I put -1 into there, 4 times -1 is -4, and -4 minus 1 is -5. Do the same thing with -2. -2 times 4 is -8, and -8 minus 1 is -9. So I have completed this table using the numbers that they asked me to complete it with, which were -2 to 2. So they're the x numbers, and I get the y values. Now, these are just coordinates. So I'm just going to plot these coordinates now. So I'm going to say -2, -9. So on the x-axis, we go to -2. On the y-axis, we go to -9. So that is the point there, -2, -9. Do the same thing with all of them. -1 is the x, -5 would be here. 0, -1 would be here. 1, 3 is there. Just be careful with your scaling here because it's 1's there, not there. 2, 7 is there, right? And then you've drawn these points. And what you should find, if you don't find this, then you've done something wrong, that they form a straight line. And then you just draw a line through it. Again, use a ruler. Don't do what I'm doing. Okay. And there is your graph of y equals 4x minus 1. So really the hard bit of it is understanding that you need to put some numbers into where the x is in this equation to get the other coordinate that you need, the other y coordinate. That's what we are doing in this kind of question. And they're always the same. So you've seen these a lot, I'm sure. It's always the same process. You just need to make this little table. Sometimes it's even drawn for you, which is quite helpful. But if it's not drawn for you, as was the case here, you just need to do that. Glad I could help. Steve is buying a car. The car costs £12,000. Steve pays 25% of the cost as a deposit. He pays the rest of the cost in 20 equal monthly payments. How much is each monthly payment? So, what a deposit is a payment that you make up front towards the value of the car. So you have to make it straight away. And then the rest of what you owe can be split over a monthly payment. That's what's happening here. So that's what a deposit is, which it doesn't, if you don't know what a deposit is, it's not always clear what to do here. So Steve pays 25% of the cost as a deposit. Now, what you therefore need to do is figure out what that actually amounts to, what that amount is. What is 25% of the cost of the car? So 25% of, so the deposit is 25% of £12,000. And we need to work out how to do that. Now, there's a few different ways to do this, but I want to focus on the way that is probably best without a calculator, because that's what this is. So I would say that you probably want to know, preferably, that 25% is the same as a quarter. A quarter of 12,000. That's what 25% is. So there's a few percentages, like 25% is the same as a quarter, 50% is the same as a half, 10% is the same as 1/10. I mean, that's probably enough, really. 1% is the same as 1/100th. Some of this common percentage conversions to fractions help if you know them, because then you can do what we've just done there and say, well, 25% is the same as a quarter. And then I can go, let's find a quarter of 12,000. And we saw a question earlier when I showed you how you find a fraction of a number. So a quarter of 12,000, remember what I said? I said do 12,000 divided by the number at the bottom. Let's do that. So 4 doesn't go into 1, remainder 1. 4 goes into 12 3 times, and then it's just zeros. So it's £3,000 is 12,000 divided by 4. And then what you do with that 3,000, obviously you don't need to write this bit, but you do times it by the number at the top. In this case, it doesn't make a difference. So £3,000 is the deposit. One other quick way that you could, if you want to remember this, to find a quarter of a number is just halve it and then halve it again. If you halve this number, you get 6,000. If you halve it again, you get 3,000. So you could have done that without the messy calculation. So the deposit is £3,000. So I have paid £3,000 towards the cost of this car. which means that what I've got left to pay is £3,000 or £12,000 minus what I've already paid, which is £9,000. So I've still got another £9,000 still to pay, but I'm going to pay that in 20 equal monthly payments. So I'm going to split this into 20 months or divide it into 20 months. Therefore, the calculation we now need to do is 9,000 divided by 20. Now I'm going to do this the short division way because I think you can. Because 20 goes into 90 4 times, remainder of 10. And then 20 goes into 100 5 times, and it goes into 0 times. So you end up with £450 per month. That is how much you will pay each month. So £450 per month for 20 months makes £9,000. And then you've already paid £3,000 beforehand, and that's why it all adds up to £12,000, which is what the car costs. In reality, that is not what happens. This person takes an exam. The exam is out of 60 marks. We need to score at least 70% of the marks to pass the exam. He scores 45 marks. Show that he passes the exam. So, two ways of doing this. But I think the easier way is to figure out how many marks you need to pass this exam. To pass this exam, you need at least 70% of the marks. So you need 70% of the 60 marks that is available. So if you get 70% of the marks, you will have passed it. Now we need to figure out what that actual number is so that we can see whether this person scored more or less than that number. 70% of 60. Again, I should go back to this actually. You know where I said that 10% is 1/10? You should probably already also know that things like 60% are 6/10 and 70% is 7/10 because it makes these questions much easier. 70% is the same as 7 over 10. 7 out of 10, that's what it is. And we're doing 7/10 of 60. So if we just do the same thing that we did before, that I've showed you 2 times now, this is the 3rd time this kind of thing is coming up, to find a fraction of an amount, take the amount, divide it by the number at the bottom, 60 divided by 10 is 6, and then take that number and times it by the number at the top. In this case, we do have something other than a 1 at the top. 6 times 7 is 42. 42 marks is the amount you need to pass the exam, and this person scored 45 marks, which means that he passed. Because 45 is bigger than 42. I might just say that, but you can put it in words if you like. And that's how you do that. So this idea of finding a fraction of an amount, I mean, we're on question 16. We've sort of seen the principle of it 3 times now. So do try to make sure that you can do that and understand that what you do is take the amount, divide it by the number at the bottom, and then times by the number at the top. That's what you want to try and do. And on a non-calculator paper, all of this should end up being nice, easy answers because they're not expecting things like decimals and things like that and halves and stuff. Work out 3/5 divided by 1/6. When you are dividing fractions, you change the question. You change the divide into a times and you flip the second fraction upside down. So the 1 over 6 becomes 6 over 1. And then you just do a times question. A timesing fractions question just means you times across. So in this case, 3 times 6 is 18. And times across the bottom. 5 times 1 is 5. That would be the answer if it had not said, give your answer as a mixed number. A mixed number means like something and a fraction, like 5.5, that kind of thing. To do that, you need to know your times tables. You need to know how many 5s go into 18. And the answer is 3, because 3 times 5 is 15. You then need to work out what the remainder is from where you got up to. So you got to 15, we were trying to get to 18, so the remainder was 3. And then the denominator of this little fraction is the same as the denominator there. So the answer is 3 3/5. That's your answer as a mixed number. But even if you, let's say, only got to here, I think you would get two of these 3 marks. So don't necessarily worry if you don't get all of the marks in the question. I think you'd always aim to make sure you get some of the marks in the question, because then you'll be fine. It's just when you start getting zeros that it becomes a problem. Work out 6.3 times 2.4. Again, various different ways that people do this, but my initial advice with multiplying decimal numbers together is to ignore the decimal points entirely, as if they weren't there. If they weren't there, this question would become 63 times 24. And to do 63 times 24, again, a bit of long multiplication, which again, you want to make sure you've practiced if you haven't, if you don't know how to do this. Lots of different ways that people do this. I'll do it the way that most people do it. I don't know what way most people do it. I think most people do this. They do 3 times 4, which is 12. And then 6 times 4 is 24, add 1 is 25. Then on the second line, they put a 0, and then do 3 times 2, which is 6, and 6 times 2, which is 12. I think what most people will do. Do whatever method works for you with that. I do this, or something similar. Some people use a grid method. Yeah, fine. Whatever works for you. I think the grid method does stuff like this, doesn't it? Something like that. And then you work it out from here, and then add them all up at the end. Yeah, whatever works. So to add these together, 1512. I'm just making sure that is the correct answer to this question. Um, yeah, it is 1512. Um, so 1512 is what you get to, but then we're not, obviously this is a non-calculator paper. Yes, it is. I have not used a calculator at any point. Hence it is a non-calculator paper. So 1512 is the answer that I get, but obviously that is not the answer to the question because I specifically ignored the points when I started this. So they need one of them, it needs to go back. What I do, and again, it's up to you how you want to do this, but what I do is I say, in the question, how many numbers were there after the decimal points in the question? 2 is the answer to that question. There was a 3 after this point, and there was a 4 after that point. So there were 2 numbers after the decimal points in the question, which means that there should be 2 numbers after the decimal point in the answer. The only way to get to that situation, to have 2 numbers after the decimal point in the answer, is to put it there so that we get 2 numbers after the decimal point. And the answer is 15.12. So we ignore the decimal points, do the multiplication, practice long multiplication if you are unsure about it, whichever method you want. Get the number. So it's 1512, and then you just have to put the point in the right place. And that's one way to do it, to realize where the right place is by going, well, if there's 2 numbers after the points in the question, there needs to be 2 numbers after the points in the answer. Another way you might prefer it is that roughly, if I said to you, estimate the answer to this question, 6.3 times 2.4, you would say something around 12. Because it's about 6 times 2, isn't it? Or a bit bigger than 12. 12, 13, whatever, right? You might guess. Because it's about 6 times 2. Just broadly speaking, it's about 6 times 2. So it is somewhere close to 12, 13, the answer. And so if the answer is going to be somewhere close to 12 or 13, that's the only place the point makes sense to go. Because if it went there, we've got 151.2. That's way too big. If it goes here, it's 1.512. That's too small. In order for it to be around 12, 13 or so on, whatever it is, that's the only place it's sensible for it to go. So that's another way to think of it. But roughly, what is the answer to this question? Very roughly. So that kind of helps guide you as to where the decimal point should go. Does anybody want to tell me what the answer to that first question is? Let's see if anybody else. 1 is the correct answer. Anything to the power 0, the answer is 1. anything at all to the power 0. Okay. No matter what it is. It's not 0, it's not the number, it is always just 1. Then it gets slightly harder. Write down the value of 5 to the power minus 2. The answer to 5 to the power minus 2. Firstly, when you have a negative power, right there. What that tells you to do is to flip over the number that you have here. Okay, so remember, just a whole number. Some people are like, how do you flip up over a whole number? Well, firstly, a whole number is just a fraction over 1. That's what it actually is. So if you flip this over, it becomes 1 over 5. So that's the first bit. All a negative power does, the negative bit of it, the minus, flips over what you've got. It's easier to understand if I said to you like 3 over 4 to the power minus something. That just flips, the minus just flips this over to 4 over 3. Right? In this case, it just flips it over to 1 over 5. So the minus has made this 1 over 5, but the 2 is still there. So the question is now basically 1 over 5 to the power 2. And 1 over 5 to the power 2 just means that you apply the power to the top number and apply it to the bottom number. So 1 squared means 1 times 1, which is 1. And 5 squared means 5 times 5, which is 25. And that's the answer to that question. So the minus flips it over. And then the power you just apply to the top and bottom of the fraction. And that's it. So just to give another example, if I said to you 2/3 to the power minus 2, let's just say if we had that question, then the minus flips this over. So it's 3 over 2. But the 2 is still there. So we still need to square everything. We square the top to get 9, and we square the bottom to get 4, and the answer is 9 over 4 of that question. Remember, squaring does not mean timesing by 2. It means timesing by itself. Yeah, that's it. Another example. Okay, the kind of question that I think, again, lots of people might look at and think this looks too hard. It's not, I promise you. There are some rules of indices that I'm just going to very, very quickly summarize. They are, if I said to you x to the power 6 times x to the power 2, you can add the powers together to simplify this. 6 add 2 is 8. You do not times the powers, you add the powers. If I said to you x to the power 10 divided by x to the power 2, the answer is x to the power 8. We subtract the powers when we're dividing, as long as this number is the same, which it is throughout this question. So that's important, that you don't actually multiply the powers or you don't actually divide the powers. Multiplying powers results in you adding them. Dividing powers results in you subtracting them. So on that basis, we can say that on the top of this fraction, I've got a multiplying thing going on, haven't I? I've got 2 to the power 5 times 2 to the power 4. I can simplify this by adding the powers together. 5 add 4 is 9. So I end up with 9 on the top. On the bottom, this 2 to the power 3 is still there. I've not touched it. Then this now becomes a dividing question because a line, a fraction, is essentially just divide, right? It's just that divided by that. When you are dividing things, you can subtract the power as long as the big number is the same, which it is. So I can subtract these powers, 9 take away 3, to give me 6. That's the answer. And that's all this means when it says this fancy thing like in the form this, where n is an integer. You can almost ignore it and just do the question based on your knowledge, and you will often end up with the right answer anyway. So it just means write the answer as 2 to the power something. And that's what I've done. 156 as a product of its prime factors. That means one of these factor tree thingies where you find multiples of the number, and if you come across a prime number, you circle it and stop. So 156. It's a difficult one to start with. So, I mean, the fact that it ends with an even number, 6, means that it's divisible by 2. Let's just figure out what it is. If you divide it by 2, 2 goes into 15 7 times, because 7 times 2 is 14, remainder 1, and 2 goes into 16 8 times. So it is 78. And 2 is a prime number, so I'm going to circle it. And then I need to do the same thing with 78. Again, 78 is definitely divisible by 2. if you're not sure, just check it like this. 2 goes into 7 3 times, and it goes into 18 9 times. 39. Okay, so that is a prime number. Then we need to figure out what 39 is divisible by. And you hopefully can tell it's divisible by 3. Like, you know, you're up to your 12 up to your 12 times table. 3 times 12 is 36. 3 times 13 must be another 3 more. So 39. So 3 and 13 is what that is. And then 3 is a prime number and 13 is also a prime number. Once you get to 2 prime numbers, you're basically finished. And so as a product of its prime factors just means multiplying the circled numbers together. And when you have the same number repeated, you should write it as a power. So 2 squared times 3 times 13 is the answer. Yeah. Then it says, find the highest common factor of 156 and 130. Now, this is quite a complicated question. I'll tell you the correct way to do this, or the way that always works. It requires a Venn diagram, unfortunately, where what you need to do is write 156 as a product of its prime factors, which you've already done in part A. So 2 cubed times 3, 2 squared times 3 times 13. And then need to do the same with the 130, which we haven't done yet. So we're just going to do the same thing again. 130 is 13 times 10. 13 is a prime number. 10 is not. 10 can be found by doing 2 times 5, which are both prime numbers. 130 is much easier. So the product of the prime factors of 130 are 2 times 5 times 13. So write those down. So there's your two numbers. You've got the product of the prime factors of one and the product of the prime factors of the other. At which point, you have to draw a Venn diagram, I'm afraid. So you draw two circles with an overlap in the middle. Okay. One of these circles represents the number 156 and its prime factors, and the other represents the 130 and its prime factors. What you want to do is look for the middle section. The middle section is whichever prime factors are common to both of these. So clearly there is a 13 that's in both of them. Put that in the middle. And clearly there is a 2 that's common to both of them. 1, 2, because that's only got 1, even though this has got 2 of them. There's 1, 2 that is common to both of them. Then you don't actually need to complete this because we've answered the question, but I'm going to complete it. The remaining factors of 156 are the 3 and the other 2, because we haven't written the other 2 in. And the remaining factors of 130 are just the 5, right? Because the 2 and the 13 have gone into the middle. When you are trying to find, once you've done this correctly, if you're trying to find the highest common factor of these two numbers, then it is just the product of the numbers in the overlap. So you multiply those together. 13 times 2 is 26. That is the highest common factor of those numbers. And if you had a question that said, what's the lowest common multiple? We don't have this question here, but it often follows. What's the lowest common multiple of these two numbers? The lowest common multiple is all of the numbers in the Venn diagram multiplied together. So not just the ones in the middle. The ones in the middle give you the highest common factor. All of them give you the lowest common multiple. So if you did 2 times 3, let's try and do this in my head. 2 times 3 is 6, times 2 is 12, times 5 is 60, 60 times 13, I don't know. If you multiply all the numbers in the Venn diagram together, you would get 780. And that would be the lowest common multiple of those numbers if that had been a question, but it wasn't. Why 26 if the highest number in there is 13? Because these numbers are not all of the factors. They're just the prime factors. I think that's the point. So these numbers here are not all of the factors of 156 and 130. They are just the prime ones. So yes, whilst you say that, so somebody just asked that, why is it 26 if the highest number in there is 13? It's because the numbers in here are just the prime numbers that are factors. That doesn't mean it can't be another number. So it is 26. I can prove it because if you do 156 divided by 26, you get a whole number. So 26 is a factor. If you do 130 divided by 26, then you get 5. So 26 is a factor. So clearly that is higher than 13. And so that is how that works. So next one. Right. This is getting slightly more tricky now. Someone just asked, can we do box plots and histograms? Possibly. It depends if it comes up on one of these two papers. And also, I've got a feeling histograms. I'm trying to remember if histograms is in foundation level or not. I've got a feeling it might not be. I'll double check. In fact, I'll double check now. If anybody knows, and tell me. I forget where the cutoff is. Yeah, box plots, cumulative frequency, and histograms are all in the higher level stuff. So I'm unlikely to get to it today because I'm trying to focus on the foundation level papers. The mean length of 5 sticks is 4.2 centimeters. This person measured the length of the higher one isn't today. The higher one was in the past. It was yesterday at 11 a.m. If you want to watch what we did in the higher level paper, but then or the high level it's one that I did, then it is on, well, it will be on YouTube later on today. I just need to go through it and get to it. I think, wait, I got this right. Yeah, I haven't put that one on YouTube yet, but it will be. Also, just to be clear, I think people again misunderstand this sometimes a little bit. They the the last few questions I have done are higher level questions. There is a massive overlap between the two when you do exam papers because the second half of a foundation level paper is basically the first half of a higher level paper. So don't just assume, therefore, that it's either foundation or it's higher. It's like, well, this question is in both. I mean, literally, it is in both. Because I've seen it in the equivalent year's higher level paper. This question was near the beginning of it. This is just near the end of the foundation. That's all it is. So the can I do a non-calc trigonometry? I'll try and come to that. Yes, I'll in fact I'll make one up. Why not? The mean length of 5 sticks is 4.2 centimeters. Now I'll measure the length of one of the sticks is 7 centimeters. So there's 5 sticks. Imagine these are the sticks. Their mean length is 7. How do you calculate the mean? You add up the lengths of all of these sticks and divide by 7, don't you? Not 7, divide by 5, because there's 5 sticks. So that's what you do, right? You add up, how do you find the mean of anything? You add them all up and divide by how many there are. So in this case, I would have added up all of the lengths, divided by 5, and got the mean. But they're telling you the mean is 7. Now, what I can do with this information is figure out what. Sorry, I got this wrong. The mean length is 4.2. I'm reading the question very wrong. Right, okay. The mean length of 5 sticks is 4.2. Right, so we have added up these sticks, divided by 5, and got 4.2. What that allows me to do is figure out what this number is, as in the number that they all added up to. Because I can do that, because surely there is a number that when you divide it by 5, you get 4.2. But if you don't know what that number is, you can figure it out by doing 5 times 4.2. It is just a rearranging equation question. So if I want to work out what these numbers add up to, you would do 5 times 4.2. Now, that is harder to do without a calculator, but I'm just going to get to it quickly because you can do it. If you just do basically that, then you should be able to get to it. Might just do it. 2 times 5 is 10. It is 21. So basically what I'm saying is that the lengths of these 5 sticks adds up to 21. Because then I did 21 divided by 5 and I got 4.2. This person has measured the length of one of the sticks as 7 centimeters. So one of them is 7. The question is to work out the mean length of the other 4. Well, as we just worked out, they all added up to 21. If I want to only find the mean of these 4, then I just need to get rid of the other one, don't I? The other one that is 7. Let me just remove that, take it away, and I'll get 14. So that means that the lengths of these 4 sticks adds up to 14, and then this one is the 7 that makes the 21. So to find the mean of those remaining 4 sticks, I would do 14 divided by 4, because now there's only 4 sticks left. 14 divided by 4 is 7/2, which is 3.5. 3.5 would be the mean length of the remaining 4 sticks. This thing that I just did here, where to find what these numbers add up to, when you are told the mean and how many numbers there are, and you have to multiply them, this thing appears quite a lot in exam papers, this idea, because you learn the mean and you know it's not that difficult. You add up numbers, you divide by how many there are. It's not a complicated thing. But that's because of that, you don't really get given an easy, simple question on it. The way the question is asked is you're told, well, here is the mean. This is how many there were. Do something with this information. And you have to understand that if you multiply how many there are by the mean, it will tell you what everything added up to, which in this case was 21, which you can then use to do stuff with in the question. I'm not going to do that. Right. What I will do, I'm not going to do that either because it's a thing. Right. I'm just going to do one question that is, I'm not going to, it's not going to be, it's not on this paper, but let me just do it because it wasn't on this one. Right. Here is a question, a non-calculator question. Right. Non-calculator question. And it asks you to work out the length of this side. This is a trigonometry question. You have to know trigonometry for both foundation and higher. However, this is on a non-calculator paper, and if you have done any trigonometry, you will recall that most of the time you did trigonometry, you used a calculator because it specifically required the use of either this sine button, this cos button, or this tan button, depending on which question you were doing. So how could you do this without a calculator? I shall tell you. So let's just go through the process of what you do first, whether you have a calculator or not. The first thing to do in a trigonometry question is to label your 3 sides. The 3 labels that you want to use are H for hypotenuse, O for opposite, and A for adjacent. Well, it doesn't really matter. And then you just first label these, right? So the hypotenuse is always the longest side of the triangle. If you can't immediately see what that is, it is the one that's directly across from wherever the right angle is. Remember, this topic can only happen for right-angled triangles. Otherwise, it doesn't exist. So across from the right angle is your H. So I'm going to put a H there. There will always be, in a trigonometry question, another angle in the question. In this case, it's there. It could be an X in a different question, but there will be another angle that you are using in the question. We're going to use this angle here. Now, the opposite is the side that's opposite that angle. So that side is the opposite, the O. Then the one that's left, there's only going to be one left, right, if you've done 2, is the A. So make sure you get the labeling correct. And that's so important because if this angle had been up here, then this would have been the O. And the O and the A, therefore, are interchangeable depending on which angle we're looking at. So we're now going to use this thing that I hope is ingrained in your mind if you have done this topic before. SOHCAHTOA. Right. SOHCAHTOA is it's 3 little formulas, really, that help you answer these questions. The point of SOHCAHTOA is that you have to determine which of these 3 little equations you're going to use in each question. The way you determine that, once you've labeled it, is to look at which side you know already. So we know the length of this side, so we're going to use that number. And which side are you wanting to find out? We're wanting to find out this one here. And so we look for in SOHCAHTOA the one that has an O and a H in it. And that is the first one here. That has an O and H. The other 2 don't have O and H in, do they? And so we will use this one in this question. What this formula tells you is the S, the C, and the T refer to those 3 buttons on the calculator, the sine, cos, tan buttons. it tells you the sine of the angle in the question. After sine, cos, and tan, just to be clear about this, we have to put in a number. You can't just press sine equals. It has to put in a number. It is a function that you put a number into, like 25, and it will tell you something after it. So the thing that goes after sine or cos or tan is always an angle. So I'm just going to put a line there to say that what's going to go there is the angle. And then the formula, when it's SOH, means that that equals O divided by H in that order. That's what this is trying to help you do, which I appreciate is a little bit confusing because when letters are stuck together, you normally multiply them. But this is how we do this topic, right? The SOHCAHTOA thing is meant to help you get to the formula, which is sine angle equals O divided by H in that order. Now, in this case, the angle is 30 degrees. So I'm going to put that in. The O is my X that I'm trying to work out. So I'm just going to change that O to X. The H is 8. So the H is 8. And now, how do we, again, let's not worry about the calculator for now, but how would you normally rearrange this to find out what X is? Well, if I gave you a question that said X over 2 equals 5, then hopefully what you would do is do 2 times 5, right? In the same way, I am going to move this 8 by timesing it by that. So it'll be 8 times sine 30. Now, on a calculator exam, you would ordinarily at this point type that into the calculator, okay? However, I'm going to find this now on here and put it into this page so that we can all look at it. There is a topic called exact trig values, which I'm just going to bring up now. This is the thing that you need to learn. So by the time you reach your non-calculator maths exam, you need to have basically learnt this table, I'm afraid, which is certain values of sine, cos, and tan. Yeah, for the values of sine 0, sine 30, sine 45, sine 60, and sine 90. And then same with cos, same with tan. It looks more complicated than it is, I promise you. If you just spend a little bit of time, you will be fine with it. The one tip I can give you is that there are lots of ways to try and learn this, like you'll see things, but ultimately what I recommend you do is try to learn this first line, definitely, which is sine 0, 30, 45, 60, 90 as being 0, a half, that, and that. And then the second line sort of recreates itself because it's just the first line backwards. If you look at it, it's 1, which is there, then the root 3 over 2, which is there, the 1 over root 2 is there, a half is there, 0 is there. So it's the same backwards. So once you learn the first line, you basically learn the second line. And then there is a little trick for the last line, but I'm not going to go to it now. You do need to have learned this. And if you have learned this, then you have learned that sine 30 is a half, which takes us back to this question now. Sine 30 is just a half. And 8 times a half is just a half of 8, which is 4. And therefore, I have done this question without a calculator because it was on a non-calculator paper. So you do need to make sure you have learnt these at the, yeah, I was going to say something at the very least, but you just need to learn it. So let's go back to, we might take a break in a minute, or a few minutes, but let me go back to some of these harder questions now. Such as this one. Somebody asked me about what angles on a straight line. They add up to 180 degrees. There's not much more to it than that. So here we have an isosceles triangle. Okay, an isosceles triangle has two sides that are the same length, and two of the base angles are the same length as well. These two are the base angles of this isosceles triangle because it kind of reaches a point there. So they're the bottoms, as it were, which means that this angle, which is x, is the same as this angle as well. Just doesn't really help yet. But then it says x to y is in the ratio 2 to 1. Okay. That means that x is 2 times bigger than whatever y is. Okay, that's ratios are horrible and there's horrible everywhere. But just understand that if two numbers are in the ratio 2 to 1, it means that whatever this number is, this is double that number. So for example, if this number was 50, this number is 100. If this number was 300, this number is 600. They always stay in that ratio no matter what. So what I'm going to do is say, well, if x is basically just double whatever y is, then why don't we change this x to 2y? Because that's what we're saying it is, right? We're saying that the x is just double whatever y is. So if this angle is y, then this angle is just always double it. So rather than call it x, let's call it 2y. Because that means that we're keeping the same letter. We're keeping it in terms of y. And in the same way, because of the isosceles triangle, we'll change that to 2y. And so because the I have determined that the angle x is double whatever the angle y is, I've sort of created a new triangle here with labels that only have y's inside. Let me just check what somebody is saying. Sampling questions. Not yet. Maybe in the we'll look at a calculator one after this, but maybe in that one. What do you know about the angles inside a triangle? The three angles in a triangle add up always to 180 degrees, which means that these three angles that I've done here, y and 2y and another 2y, have to add up to 180 degrees. They have to, because they are the three angles in a triangle. And hopefully now you can see why it was helpful to change this x into a y, because now I can add these up easily. Y add 2y is 5y. And y is 180 divided by 5. And then let's work out 180 divided by 5 is 5 goes into 18 3 times. Because it's 15 remainder 3, and 5 goes into 30 6 times. So it is 36. So I have now worked out that y is 36 degrees. Which means that if we needed to know what x is 72 degrees, because it's double it, right? But that's not what they've asked. They've asked you to work out the value of w, which is here. So I now know that y is 36 degrees. This is a straight line. It tells you in the question it's a straight line. And you should know that, of course, the angles on a straight line add up to 180 degrees, which means that we can work out what w is by doing 180 take away 36. And you get 144. And that is what w is. That's how we do that. Quite difficult now, but we are at the second part of the paper. So these get slightly tricky. Right, let's do one more. And then we might just take a break for 5 minutes and before I do this density bit. This person has 3 shelves of books. Here are my 3 shelves. There are X books on shelf A. There are 3X plus 1 books on shelf B and 2X minus 5 books on shelf C. There is a total of 44 books on the 3 shelves. Okay, let's stop there for a moment. I should be able to work out, well, how many books are on each shelf now, because I know that the number of books on each shelf added together makes 44. Okay. X add 3x add 2x is 6x. Plus 1 take away 5 is minus 4. 6x equals, if you add the 4 over, 48. And if you divide by 6, 48 divided by 6 is 8. I'm just speeding this up a little bit because it's a harder question. So I have worked out that x is 8 from all of that process. Okay, just be careful when you're simplifying stuff like this. Be careful of minuses. A lot of people make this mistake. But be careful. That's a minus 5, so it was 1, take away 5, which gave me this minus 4. Right, now that I've worked out what x is, I know how many books are on each shelf. If x is 8, then there's 8 on this shelf. If x is 8, then there's 3 times 8, 24, plus 1, 25 on that shelf. And if x is 8, there's 2 times 8 is 16, take away 5, which is 11 on that shelf. And we have our books on each shelf. The books on shelf B have a total mass of 7,500 grams. Work out the total mass of the books on shelf A. So this is interesting. All the books have exactly the same mass. That's a really important point now. So if these 25 books have a mass of 7,500 grams, I can work out the mass of one book quite easily because I can do 7,500 grams, which is what all of those 25 books weigh, and divide it by 25. 7,500 divided by 25 is 300 because 25 goes into 75 three times and then it's 0, 0. So 300 grams is one book. The question is, work out the total mass of the books on shelf A. Well, on shelf A, there were 8 books. One of them weighs 300 grams. So I'm going to do 8 times 300, which is 2,400 grams for the books on shelf A. And that would complete that. You know what, I was going to keep going for a second and try and finish this. In paper, yeah, just for the last few questions, which I appreciate are going to be slightly harder. But there is a formula in maths. You should make sure you remember it in case you don't get given it. But density is mass divided by volume. So in this case, that's a very easy question because the mass is 27, the volume is 10. You do 27 divided by 10, and you get 2.7. And that's the answer to the question. Work out an estimate for this. Okay. Estimating in questions requires you to make the numbers just easier for yourself to within a limit, right? So you can't get too far away from the number. So for example, I could call that 6 and I would call that 8, right? Rather than 5.7 and 8.2. And then this 0.26 is a little bit of a tricky one, but I'm going to call it 0.25 and I'll explain to you why I've done that later. What do we have here? We have 6 times 8 on the top, which is 48, and we're dividing by 0.25. How do I do 48 divided by 0.25? Well, let me write it out differently. 0.25, what's that as a fraction? It's a quarter, isn't it? 0.25, like 25% is a quarter. So what I'm really doing is dividing by a quarter. How do you divide by a quarter? Well, from your keep, flip, change thing for division of fractions, you times and you flip over. So this question is really just 48 times 4 because the 1 doesn't even matter. So really it's just 48 times 4, which is 192. That is my estimate for this question. And then some expanding and simplifying. Before we move on, I'll do a calculator paper for the remaining part. To expand these brackets, you need to make sure that everything in one bracket is multiplied by everything in the other bracket. So do it really slowly. Take the first thing in the first bracket, times it by everything in the other bracket, like that. So 3x times 2x is 6x squared. And 3x times minus 5 is minus 15x. Then move on to the next thing in the first bracket. There is that. 2 times 2x is 4x. And 2 times minus 5 is minus 10. And now what you just need to do, you will usually end up with a bit in the middle that can simplify. Minus 15 plus 4 is minus 11. Just really be careful when you're doing negative numbers and adding them. And that is your expansion and simplification of those two brackets. And then I'm just going to do this quite quickly, but if you factorize this, the answer is x plus 4, x minus 4. It's called the difference of two squares. It's something you just have to spot. So you spot that you have a square number here, something squared, and you spot that you have a square number here, that is 4 squared, and there's a minus in between them. When you have that situation, it always factorizes like this. It's x plus a number, and then x minus the same number. So if I said to you x squared minus 25, what does that factorize to? It would be x plus 5, x minus 5. In other words, the number is the square root of whatever number you have there. So it becomes x plus 5, x minus 5. Right, that is all of a non-calculator paper. We shall have a look at a calculator paper immediately after this. Yeah, and what we'll do that in 4 minutes for the remainder of the hour. Okay, so I'll be back in 4 minutes. Um, you could make a so somebody's asked if they can list some topics. Yeah, some people have been doing that. If you list some topics, I'll try and see if we come across some of those questions as we go. Um, and then we'll see. Right. Okay. Two factors of 18. Factor those numbers that go into the numbers. The easiest answer here is 1 and 18, but you could have said 2 and 9, 6, 3. Any of those are factors of 18, numbers that go into 18. Um, Writing a decimal as a fraction. Again, I'm going to skip through the early questions quite fast, but if you have a problem with any of them, then just tell me. 0.9 as a fraction is 9 over 10. When it comes to writing decimals as fractions, if I, for example, had 0.32, then you take this number for the top, and on the bottom, you put 10 if there's one number after the point, like I did here, and you put 100 if there's two numbers after the point. If it was 0.123, then that would be 123 over, because there's three numbers after the point, 1,000. Um, Mixed fractions, improper fractions. Well, we had one of those questions with a mixed fraction earlier. Simultaneous equations we might see, and bearings we might see as well in a minute. I don't know for certain, but we'll see in this paper. 7 meters to 100 centimeters. There are 100 centimeters in 1 meter, which means that in 7 meters, there are 700 centimeters. The square numbers are the answers to 1 times 1, 2 times 2, 3 times 3, and so on. The answers, really important. So the answers, things like 1, 4, 9, 16, 25, 5 times 5, 36 for 6 times 6. 7 times 7 is 49. 8 times 8, 64. So if we need a number between 10 and 50, that is a square number, then we can pick any of those, I guess, between 10 and 50. Yeah, any of those would be the answer. 50% of 240. Again, like I said earlier, if you know that 50% is just a half of it, then you halve it, right? And half of 240 is 120, which you could do by doing the bus stop divide by 2 method if you didn't know. Lydia works for 4 hours. She is paid £50. How much is Lydia paid per hour? This is a division question. Let me just see if anybody's asked anything. Um, Growth and decay. I'll try. Yeah. It's a percentages, isn't it? It's just a percentage increase. I'll do that. I'll do it at the end. Lydia works for 4 hours. She is paid £50. How much is Lydia paid per hour? Well, if you want to work out how much you're paid per hour, you take the amount that you get paid and divide it by how many hours you've worked. So you're really doing 50 divided by 4 here, which is easiest to do. When you're doing with money, it's easiest probably to put a 0.00 after the number. Because then if there's any pence involved, you sort of deal with that as well. So if we do 50 divided by 4 like this, put the point here. 4 goes into 5 once, remainder 1. 4 goes into 10 twice. 4 times 2 is 8, remainder 2. 4 goes into 20 5 times. And then 4 goes into 0 0 times. And then you get to your answer in pounds and pence. So it's quite nice. So the answer is £12.50. What is the name of this? Looks like a cone to me. Draw a sketch of a triangular prism. Toblerone is what I would suggest. That is a triangular prism. We need to buy some items for a sports club. Here are the prices. Football, hockey sticks, cricket bats, tennis balls. Curtis needs to buy all of these things. He has £200 to spend. Show that he can buy all the items he needs. So we need to do some. We've got a calculator now, haven't we? So I need to get that ready. So 5 footballs. What do 5 footballs cost? They are £9.50 each. So let's just do this on a calculator. £47.50. Sorry, I forgot in that previous question we could have just used a calculator as well. 6 hockey sticks. They're £30 for 2. Be really careful with this because it's £30 for 2, which means that if we need 6 hockey sticks, we need 3 of this offer basically to get the 6 hockey sticks. I think people can mess this up a little bit. So if I times that by 3, I will work out the price for 6. So 30 times 3 is 90 for 6. So £30 for 2. Okay, so 6 hockey sticks will cost £90. 2 cricket bats, they're £23 each. 23 times 2 is 46. 4 tennis balls, it's £5 for 4 tennis balls. So it's just £5. So let's work out what all of this adds up to. And you will get £188.50. So therefore, clearly, he's got more than enough money because £200 is more than £188.50. Harris is buying a shirt and tie. He has a choice of 3 colors of shirt, white, blue, green, and 3 styles of tie. Harris is going to choose 1 shirt and 1 tie. List all the possible combinations Harris can choose. So the way I would do this is I would take a shirt, white, and list the ties that can go with it. So we can get a white shirt and a plain tie, a white shirt and a striped tie, a white shirt and a checked tie. Then move on to the next type of shirt. We could get a blue shirt with a plain tie, with a striped tie, with a checked tie. Or we could get a grey shirt with a plain tie, striped tie, checked tie. That way you make sure that you count every option. That's how I would do it. There are 24 red and 40 blue in a bag. Write down the ratio of the number of red counters to the number of blue counters in its simplest form. So there are 24 red, 40 blue. We need to simplify this ratio. A ratio is basically the same as a fraction. So it simplifies in the same way as well. So the trick here in your calculator, if you write 24 and 40 as a fraction, like that, then it will simplify it for you. That's what calculators do. They just simplify it if it's possible to simplify it. So this simplifies to 3/5, which means that 24 to 40 simplifies to 3 to 5. So that's a nice little trick for your calculator that it can do this simplifying thing for you if you just put in the right numbers. Rima is going to roll a fair 6-sided dice. Choose the word that best describes the probability that the dice will land on the number 3. So on the number 3 on a 6-sided dice. Well, it's not impossible. It's not certain. Okay, so let's rule those out. It's not evens, because evens would be if there was as many 3s as total options on the die. So if there was half a chance, but there isn't half a chance, right? There's less. There's 1 3 out of 6. So effectively the probability is 1/6. It's not likely, because likely means more than a half. It's unlikely is the word that I would go for here. The probability of landing on a 3. That doesn't mean it won't land on a 3. It's just that there's 5 other numbers. There's 1, 2, 4, 5, and 6 that it could land on. So it's more likely to land on one of those than it is to land on a 3. Choose the word that best describes the probability the dice will land on an odd number. So what are the odd numbers on a dice? They are 1, 3, and 5. So half of the numbers on a dice are odd numbers, and half of the numbers on the dice are even numbers, which means that it's evens, which means that it's the same. It's a half, essentially. Half a chance of doing it. A car travels at 37 miles for 3 hours. Work out the distance the car travels. You should know that there is a formula for distance, which is speed multiplied by time. So if we're working out the distance, we take the speed, 37, multiply it by the time, 3, and you would get your answer. 111 miles. See if somebody's asked a question. There is nothing tomorrow, unfortunately. I am doing other stuff all day tomorrow. So this was it that we were going to do during this Easter holiday. There were going to be 4 sessions, 8 hours worth. So I did 4 yesterday. I'll do these 2 now, and then I'll do 2 more this afternoon, focusing on slightly harder science stuff. Triple science stuff mainly. Milo is trying to find the area of this rectangle. He writes, the area is 400 centimeters squared because 5 times 4 times 5 times 4 is 400. What is wrong with the method? Well, to find the area of this shape, you just do 5 times 4. You don't times all of the numbers together to find the area of a shape. You wrote time, wrote it lowercase t, so I don't know what you mean by that. You wrote time, wrote it lowercase t. I don't think that makes a difference. Okay. So the area is 400 meters squared because 5 times 4 times 5 times 4 is 400. Explain what's wrong. Well, what's wrong is that the area of a rectangle is just the length times the width, not all of the numbers times together. Um, this afternoon, 3 o'clock. 5 times 4, 20. So that it should be 20 basically, because what he's done is times all of the numbers together. He should only be times the length and the width. Anya works out the area of a shape. Her answer is 86. Explain why her area of a shape. Oh God, that's horrible. Um, the only thing that's wrong here is the YouTube is I'll put the link in the chat in a second. If I'll do it now. Do Okay, so there is a YouTube there which should take you to the channel in which the what I'm doing right now is going to be on there later on. What I did one of what the session I did yesterday is on there already. The other one that I did yesterday I'll put on later on today. I just need to edit it slightly. And then what I do this afternoon at 3 to 5 will also hopefully end up on there. Or I do quite a lot of other weekly sessions with the students that come to us regularly. And all of those go on the YouTube as well. Afterwards, they won't make a lot of sense because I mean I go through the homeworks that we set, but they will still be useful. And then other things I will be posting in the next over the next month and throughout. Um, so a lot of you might be, some of you might be here through the Instagram thing that I do, where there's quite a lot of the quizzes and stuff that I put on there, which I think are quite useful for you to do whenever I have time. I just do one, think of a question and stick it on that is relevant to mostly science stuff. The answer to this question: does anybody actually know what's wrong here? I suspect this is not obvious, but let's see if anybody actually knows. Like somebody works out the area of a shape, that's their answer. Why can the answer not be fully correct? What is wrong with what we see here? Yes, it's squared. So the units for area have to be centimeters squared or meters squared or kilometers squared or something like that. They can't just be centimeters. It can't be. The unit is different, literally. Okay. And there you go. Right. 3 kilograms of flour costs £4 and 5. 5 kilograms. Work out the cost of 2 kilograms of flour and 5 kilograms of sugar. The easiest way to do these questions, especially since you have a calculator, is just to figure out what 1 kilogram of something costs, and then you can work from there. So if I know that 3 kilograms of flour costs £4 and 5, if I divide that by 3, I will know what 1 kilogram of flour costs. 1 kilogram is £1.35. So 1 kg of flour is £1.35, according to my calculator. Then it says 5 kilograms of flour and 6 kilograms of sugar. So 5 flour, let's call it, and 6 sugar. Let's call that G because I don't like writing S's. Cost £11.85. Okay. I know what 5 kilograms of flour costs because I know that one costs £1.35. So let's times that by 5. That means the 5 flour costs £6.75 plus something costs £11.85. So what I'm going to do now, let me see, is this the best way to do this? Yeah. What I'm trying to do is figure out what 1 kilogram of sugar costs. And because I've done this now, I'm about to find out what 6 kilograms of sugar costs by taking £6.75 away from £11.85 to give me £5.10. That's what 6 kilograms of sugar must cost. So if I divide that by 6 now, it tells me that 1 kilogram of sugar costs 85p. Now that I know that, I can answer the question, which is the cost of 2 kilograms of flour. So a flour is £1.35, plus 5 kilograms of sugar. A sugar costs £0.85. And then you do it. So that's 2 kilograms of flour plus 5 kilograms of sugar is £6.95. So with these questions, the easiest way to do it with a calculator especially is to figure out what 1 unit of it costs. And then you can work it out from there. Okay, these two share £120. Martha gets 72% of the money. So Martha gets 72% of £120. Now, with a calculator, doing percentages is really easy. There's so many ways to do it. You could change the percentage into a decimal, so 0.72, and then just times it by the number, and you get £86.40. So you don't need to worry about any other way of doing this in non-calculator methods and things. You can just do that. This will automatically end up on YouTube, this video, or everything I've done for the last hour and a half will automatically end up on there later on today. It should be automatic. But it's being recorded elsewhere, so if you have any issues finding it, then you can just message us. But that is £86.40. Now, let me just tell you another way to do the same thing on your calculator. If I want to find 72% of something, then there is a percentage button on some calculators, depending on which one you've got. In my calculator, it is there above that answer button. So if I do shift and that answer button, it turns it to 72%. If I times that by a number, I will work out 72% of that number, which is £86.40 again. So Martha will get 72% of this £120. So she gets £86.40. It says that she will spend 30% of that money that she gets. So she gets this much money, she's going to spend 30% of it. Let's work out how much she spends. 30% of £86.40 will do 30%. Oops. Remember, you could just turn it into a decimal, 0.3. Times £86.40, which is 25.92. So she spends £25.92. The question is, how much money does Martha have left? That would be how much she got minus how much she spent. Right, since a few people are asking about compound interest and decay and stuff, then I will go through that. I'll see if I can find anything on it. And was there something else? Bearings and simultaneous equations. Let's see if I can find anything on that. That I'm not doing. Let's do this. I can give some people are asking about compound interest. So we invest £4,500 in a savings account for 2 years. The account pays compound interest at a rate of 3.4% per year. How much money does Andrew have in the account? Now, I'm going to change the numbers a little bit because what makes things a little bit complicated is when you have a decimal here. I'm going to change it to 20%. 25%, very unrealistic number, but let's make it 25% compound interest. Okay. Now, the way interest works is that you increase the amount of money that you start with by that percentage, whatever the interest rate is given to you in the question. So in this case, 25%, we increase by 25%. Now, There are a couple of ways of increasing numbers by percentages. You could do what I've just done, which is find the percentage of the number and then add it on. But you don't really want to do that in compound interest questions because it can be quite long and make a mistake. So what you have to realize, and this is the crucial thing, you have to understand that when you increase or decrease a number by a percentage, you can do it using something called a multiplier. You have to figure out what that multiplier is. If I want to increase by 25%, if you want to figure out what that multiplier is, then what you do is you start with 100% and add on the number that we have here, so 25%. If we add 25% to 100%, we get 125%. Now, what I then do is turn that number into a decimal. And it's easy to turn a percentage into a decimal. You just move a decimal point back two places, and you get 1.25. Now, this is what I like to call the multiplier. The multiplier, what it does is it will, if you times it by any number, it will increase that number by 25%. Okay, so if I want to increase 4,500 by 25%, I can just times it by 1.25. That is all that will happen. It will automatically, I will increase it by 25%, and it will end up on 5,625. That will increase it by 25%. If this number had been 5%, let's just say, then I would have been doing 100% add 5%, and I've got 105%, and my multiplier would have been 1.05. So timesing by 1.05 increases anything by 5%, and it will increase it by 5% to 4,725. If we are increasing by 3.4%, this is where it gets a tiny bit worse, then I'm going to add on 3.4% to 100% to get 103.4%, and then move the decimal point back two places to get 1.034. That is the multiplier. So we've just asked, couldn't you find 25% of 4,000 and add it on? You could, and that would work. The problem is you would then need to do that whole thing again to do this over 2 years. And if the question had said 5 years, you would have to do all of that again 5 different times, and it would take you forever. So by doing it this way, it will speed up the process, as you will see. Because what this does now is increases 4,500 by 3.4%, because that's what this question is asking us to do. Okay? So, and that it does that every year. So if I wanted to do this for 1 year, I would have this much money in the bank account. But the question says to do it for 2 years. So what you now have to do is just, and this is the quick thing, is that if I want to now increase that by 3.4% again, I just times it by 1.034 again. Otherwise, what you'd have to do, if you found 25% and then added it on, is now find 25% of that new number again, and then add it on. And if I had to do it 4 times, you'd have to do it again and then add it on. It would just be a very lengthy process. For 2 years, to be honest, it's not that big a deal. You could do it that way, but you just remember you've got to do it twice because it's for 2 years. But this way, you basically just get straight to the answer, 481120. Yep. So what we've done there is said, okay, I've got £4,500 in my bank. I'm going to increase it by 3.4%. Which is 1.034. Okay, that increases it already. I'll answer that last question in a second. That will increase it by 3.4%. But I need to do it for 2 years. So what you can then do is put a power on this and put a 2 on it, because all that does is it times it by that multiplier again. So you need to do it twice. And it'll get you straight to the answer. Now, if the question had been do this for 10 years, just change that to a 10. That's why that multiplier is so helpful, because it works now in a bigger length of time. If you've got that number, which I got, as I showed you, like this, then you just keep changing the power and it'll just keep on telling you the correct answer, which is how much money you will have in your account after that many years. Somebody's asked, why wouldn't you times it by 0.25? I assume you meant for when we did the 25% question, because there is a difference between finding 25% of a number and increasing it by 25%. I think that's the fundamental difference that people get a bit confused about with this topic. 25% of a number is just a quarter of the number. But if we're increasing by 25%, it means you take that number, the quarter of it, and add it on. And so I'm trying to get that. I don't know what your question you're referring to. Do you want to repeat what you said? Oh, the bit about the simultaneous equations and bearings. Is that what you're talking about? So that was a compound interest question. Again, the crucial thing is, can you get to this multiplier and then you need to do that. Now, let me just do one more question on about decay or a decrease situation. If I said to you, so that works for any type of growth, by the way. So interest is a type of growth. Um, I did answer that question. Yes, you could find 25% and add it on. Um, right. You could find 25% and add it on, but you would have an issue with that. Right. Okay. So you'd have to just do it again and again. Right. Just because of the time, I think I'm going to have to stop now, and I will revisit here at 3 p.m. if that's all right. 'Cause I've got another lesson starting at 11 o'clock. So hopefully that was helpful. As I say, it will end up on the YouTube stuff later. If you want to do some science later on, it will be reasonably complicated science, but it will be at 3 p.m. today. So I will see you then. We're doing some science. It'll be a mixture of biology, chemistry, and physics, but it's going to be triple science content. Reasonably high-end, complicated stuff because I did the easier stuff yesterday.